Hello all, welcome to CodeUp. Today let us solve the third problem of the weekly contest. The problem is nothing but remove nodes from linked list. So we are given the head of the linked list. Remove every node which has a node with strictly greater value anywhere to the right of side of it. So return the head of the modified linked list. So this is the linked list that are given. Why is the answer is 38? Because for 8 there is no greater value to its right side. So 8 is in our answer. Then 3, there is a 8 which is greater than 3, so we have removed 3. So for 13 there is no greater value that is on the right side, so we restore 13. And for 2 there is a greater value 13 which is on the right side, so we remove 2. And for 5 also there is a greater value 13 which is on the right side, so we remove 5 as well. So the answer is 13.8. So this can be done very easily using an extra space. So what we do is 5 to 13 3 8. So 5 to 13 13 3 8. So this is our linked list. So we can use an extra space and we can store them in a vector. Once we have stored them in a vector, we can just calculate the suffix array in the sense storing the maximum element from right side. So if I store the maximum element from the right side, which is nothing but 8, then there is a 8, then there is a 13, then there is a 13 again, then there is a 13 again. So this is the suffix array that I can form, right? This is the suffix array. If I have the suffix array, I can easily check whether for 5 there is a greater element which is strictly greater than 5, and for 2 also there is a strictly greater than 2, and there is 13, there is no element which is strictly greater than 13, so obviously 13 stays in our answer. And for 3 there is a strictly greater element 8 to its right side, and for 8 there is no any element that is strictly greater than 8. So by using the suffix array, we can easily form this we can easily solve this problem using an extra space. Now let us see the code. So I have a vector, then a current pointer which is pointing to head, and I'm just storing the all the values into my vector. Then I have taken the size of the vector, and then I have assigned a size of n plus 1 for the suffix array. We are initially having an int min. So to avoid the boundary case, I have the size n plus 1. So now from coming from the last value, I am just storing the maximum value of v of I or the suffix of I plus 1 easily in my suffix of I. So this is the building of this suffix array, suffix maximum array. Now next is our answer to build our answer. So it is a list. So I have a new head list that is initialized with the dummy node, and then dummy head, and then current pointer is going to point to the new head. And I'm just checking if my suffix of I is lesser than or equal to v of I, then the current value does not have any strictly higher value to its right side. If it is so, then what I will do is I will just create a new node. Once I have created the new node, I will point it to that next point the current of next to the temp, and I will move the current pointer, and finally I will return the dummy node of next. So this gets accepted. Hope you like the solution, and the time complexity will be order of n, and the space complexity is also order of n. So hope you like the solution. Let me know in the comments. Let us see in tomorrow's next week's weekly contest. Until then, bye.